What's up, Jackson? Big question.
Yeah, yeah.
Allergies are annoying.
Okay. For Bellworth today, we've got a review question from chapter 4, find the coterminal angle for the given angle, and an ACC review question. I'll give you 4 minutes to try them on your own, and we'll go over it. Okay, so does anyone remember what I have to do this angle to find a coterminal angle?
Add or subtract 2 pi.
Add or subtract 2 pi, because every 2 pi is a revolution around, right? So if I add 2 pi, I just go another time around clockwise, no, counterclockwise, or if I subtract, it's another time around clockwise. They'll still end up at the exact same spot. So if you take 13 pi over 6 and add or subtract a full revolution, I'm going to go ahead and subtract. We'll get its coterminal angle. To subtract these, we need a common denominator, so that would be the same as 12/6, which is pi over 6. So in other words, you're thinking that angle, pi over 6, is this one right here. Well, that's coterminal with this angle that goes all the way around one full revolution and then stops at that spot. All right, question on number 1. Okay, so no both 3 games. In the first game, in the second game, he scored 10 more than the first. Third game, he scored 10 more than the second. Average was 230 for all 3 games. How many points did Noah score in the third game? Does anybody have an idea of how we could start this one? What'd you do?
So since his average is 230, I put it as his second game. And so then like his game before would have been 220 and his third game is 240.
That's right. That does work. The answer is 240. Yes. Since they're evenly distributed, right? 10 less and 10 more, then the second game should be his average, right? Those should be the same amount. So if we let X be his second game, it should be 230. And then to get his third game, he just scored 10 more. That is a lot easier than the way we did it. We let X be the first game, so that it was X plus 10 plus X plus 20, and set that equal to 230 times 3. 230 times 3 would give you the total number of points he scored, right? Because an average is your sum divided by how many games. So to cancel out the divide by 3, multiply by 3, solve this for X, but in here, X represents the first game. So then you add 20, you still get 240 as an answer. And a lot of different ways you can do that one. Questions on the bell work? Okay, I think you all are going to like chapter 6, additional topics in trigonometry, because it's a lot more of like, or at least similar to how you've been doing problems in trigonometry back in geometry, where it's like, here's a triangle, find the missing angles and sides using, here's a formula. The only difference really is we're going to be doing not right triangles, but oblique triangles. And so they have their own formula, which is called the law of sines. Okay, we're going to cover this one today. We'll cover these 2 tomorrow. There is no homework due tomorrow. Homework is due Wednesday. All right, so what do I mean by an oblique triangle? An oblique triangle is a triangle that does not have right angles. So you do not need to write down the second point. I would just write down this definition in this picture, because this picture is basically what all your formulas are going to be based off of. That's a notation we're going to use, where we will represent angles with capital letters. And the sides opposite that angle is the same letter but lowercase. So angle A here, capital A is the angle, lowercase a is the side, and little a is always going to be opposite big A. Same for B and C, same for C, yeah, same for B, big B, little b, and same for big C, little c. not all oblique triangles can be solved. You need the following information to do it. Today, we'll talk about how to solve them when you're given two angles and a side. Tomorrow, we'll do B, and then Wednesday and Thursday, we'll do C and D. So I'll give you time to copy that picture down and that definition. Okay, questions? Anybody need more time to write? Okay, let's do it. All right. So to do that, here is the formula you will use when you're given two angles and a side. It's called the law of sines. You don't need to include this picture. This picture is just a reference for a proof that we will do. All you need in your notes is the law. Oh, the law of sines. Which, if you look at your trick sheet, is on it on the back. So they do sine of A over A equals sine of B over B equals sine of C over C. But that's the same thing, right? If you flip each of those, as long as you do it to all three, that is an equivalent expression. It's actually just not quite as useful for most of the problems you're going to do. So I'm sure you're wondering, well, where did this formula come from? Well, let me show you. The law of sines can be proved actually pretty easily, so we'll go ahead and do it. So if your triangle is oblique, that means it's either acute or obtuse. It has no right angles, right? So either all the angles are less than 90 or one is greater than 90. In either case, though, you can notice that for angle A, the opposite side to angle A for this right triangle or for this right triangle is the same amount. It's the altitude h. And the hypotenuse of each of these right triangles is side B. So for either situation, it turns out that the sine of angle A for the right triangle is opposite over hypotenuse h over B. And if you solve that for h by multiplying by B, you'll get h is equal to this B times the sine of A. Make sense? And you've actually probably done that before if you're on the ACT or maybe for geometry homework where they gave you a triangle that wasn't a right triangle. You have to like make your own right triangle. Find the height. All right, if we do that for again, but using angle B this time, you will see that for angle B, for its right triangle, the opposite is h for this one. And, okay, if you look at this one for angle B, the right triangle here is this huge right triangle. So for angle B, opposite it is also h. And the hypotenuse of this right triangle is A. And the hypotenuse of this right triangle is A. So you can see in either case, the sine of angle B is the opposite side H over the hypotenuse A. And if you solve that for H, you get H is equal to A sine of B. And since both of those expressions are equal to H, we can then set them equal to each other to get B sine of A is equal to A sine of B. And so if we want our formula here to look like it is given here, we're just going to divide by the sine of our angles, divide by sine of A and sine of B to both sides. You'll see on the left side, the sine of A's cancel out, and we get B over the sine of B equals. On the right side, the sine of B's cancel out, you get A over the sine of A. Isn't that neat? All right, so that equates those two. To equate C, we won't actually go through it. Proof is very similar though. All you do is change the base. So like if we make A the base now and look at the height from A, that'd be the height is now this H, not this. And then you'll find that C over the sine of C is the same as B over the sine of B. And then if you do the height from B, you'll get sine of A, or A over the sine of A is the same as C over the sine of C. Isn't that cool? Ultimately, though, you don't really need to know where this formula came from in order to use it. Does anyone want more time to write? Because ultimately, we're just going to use this to solve problems like this, where I'm given a triangle that's not a right triangle, two angles, and a side. So to find the missing parts of this, angle A, side A, and side C, the first thing you should always do is find your missing angles. To find angle A, note that all three angles of this triangle have to add up to 180, right? So then A will have to be whatever's left over after we take these amounts from 180. So A will be 180 minus 102.3 minus 28.7, which is, pretty sure it's 49. It is 49. So that's the first thing you should always do is find your missing angle, because all three angles have to add up to 180. And then it doesn't matter if you find little a or little c next. If you want to find little a, then we're going to use the law of sines. Little a divided by the sine of A is equal to, okay, now you have a choice. You can do B over sine of B or C over sine of C. But only one of those is actually useful to us. We want to do B over sine of B because that's the ones that we know. That's the pair that we know. So we want to use that pair in our formula. So we're going to set this equal to B over sine of B, not C over sine of C. Because again, we don't know what C is. This setup, I have 4 variables, but I already know what 3 of them are. If we plug in those amounts, we get A over the sine of 49 degrees is equal to 27.4 over the sine of 28.7 degrees. And now the only variable I have left is a. And I can solve this for a in one step. I just need to get rid of the dividing by sign. So the opposite of dividing by sign is to multiply. So a will be sine of 49 degrees times 27.4 over the sine of 28.7 degrees. And then we just type that into the calculator, making sure our calculator is in degree mode. And you get A is about 43.061 feet. Okay, now that you know what big A and little a is, when you solve for C, you can set it to either B over sine of B or A over sine of A, right? I would encourage you to still use B over sine of B because these you know are right. This one, maybe you accidentally put your calculator in radians and it gave you the wrong answer, right? So to find C, we'll do same thing, C over the sine of C equals B over the sine of B. If we plug in our values, we get C over the sine of 102.3 degrees equals 27.4 over the sine of 28.7 degrees. No big parentheses there. To solve this for C, we need to get rid of the divide by sign, so we multiply. C is the sine of 102.3 times 27.4 divided by sine of 28.7, which makes C a boo. $55.747 feet. Okay, so to check your answer, what I would usually recommend you do, I mean, you could just plug back into the line slides, make sure each ratio is giving you the same amount. But there is a way to spot check your answer and be pretty confident you got it right by looking at your final product. Each angle, depending on its size, should be opposite the corresponding side, depending on its side. So B is our smallest angle, so it should be opposite the smallest side, and it is. A is in the middle, it's the medium angle, so it should be opposite the medium side, and it is. C is the largest angle, so it should be opposite the largest side, and it is. So that's a really easy and fast way to spot check your answer and make sure you didn't accidentally divide instead of multiply, or that your calculator is in radians instead of degrees. Yay? Questions about that? Okay, let me ask you one more question before I have you try one. After I found A and I had B, could I have used the Pythagorean theorem to find C? You think so? hopefully, if you say yes, you still won't get in trouble, because if you then go to set it up, which is the hypotenuse? Which one's opposite the 90-degree angle? Yeah, there is no 90-degree angle, right? Like, which one's the hypotenuse would be arbitrary. That doesn't exist for this triangle because there's no right angle. So the Pythagorean theorem will not work. Actually, what you should get when you do the Pythagorean theorem, I don't know, if you had me in geometry class 2 years ago, we classified triangles based off the Pythagorean theorem. And if a squared plus b squared is less than c squared, then you knew it was an obtuse triangle. So you should get the a squared plus b squared is less than c squared for this one. But long story short, you cannot use the Pythagorean theorem because it's not a right triangle. You have to use the law of sines. So don't let the lettering of ABC mess you up there. ABC is just, easy letters to use. Actually, just purely coincidence that those are the same letters we use with the Pythagorean theorem. All right, let's have you try one. I'm excited. Given this right triangle, find angle C, then find side C and side B. I'll give you 3 minutes to try it on your own. Then we'll go over it. We need one more. Yeah, okay. Let me add 2 more. I'll go ahead and walk around. If you have nothing on your paper, stop, let me know. I'll help you out. Actually, hold on, let me check. Yay. Formulas? So it's the same as those, but just flipped so the little a is on top. All right. On the right track. Oh, wait. Hold on. You're- You're okay? Okay, you do the exact same thing as Jason, isn't it? Your A is 32 in this case.
Oh.
So this should be sine of. So that should be 32 over sine of 30. And this should be sine of 45 over B on top. Okay, it sounds like we're all kind of in a good spot. There may be some like notation, which I'm happy with. And if I count correctly, I think we've got 3 problems here and like 4 people that I could call on really easily. So let's just roll a dice and everybody gets a turn. So Anna, you get to start us off. How do I find angle C?
You take 180 and you subtract the 30 and the 45.
Yeah. So that I believe is 105. Okay, Ty, you want to find side C or side B first? Okay, so then we're going to do B over the sine of B equals, okay. Now, should we set this equal to A over the sine of A or C over the sine of C? That's right, because that's the one we're given. So we plug in, we get B over the sine of 45 degrees is equal to 32 over the sine of 30 degrees. And then Ty, you got one more step to solve this for B. How do we get rid of the dividing by sign? Multiply. So B will be sine of 45 times 32 over the sine of 30. And then we type that into a calculator. Sine 45 times 32 over sine of 30 is 45.255. Oh, there wasn't no units, so 45.255. Okay, Jackson, can you help me out with C? What should we set C sine of C equal to? That's fine. You could also have done A sine, oh, I just wrote it, A sine A, because now we know all of that stuff, right? We know little a and big angle and A. We know little b and angle B. All right, so if we plug in, we get C over the sine of 105 degrees equals 45.255 over the sine of 45. And then Jackson, you got one more step to solve this for C. That's exactly right. Very good. All right, if you do that, you get sine of 105 times answer divided by sine of 45, 61.819. Caitlin, how do we know that those answers are pretty good answers? How can I spot check? Make sure that that's right. No, you don't need to add them, though that could be fun. My smallest side is 32, right? What's my smallest angle? So those are opposites, so that works. And is it also true that my largest is opposite my largest? Yes. And then the medium is opposite the medium. Now, that's a good spot check. Just to make sure that you don't know exactly right, but to be honest, if all that works out, it would be hard for you to not be right. Usually, if you have an error, it'll be like dividing instead of multiplying, or having your answer in radians instead of degrees, or plugging in the wrong thing, and that'll drastically affect your answer. Should totally mess it up. Like radians will often give you, if you're getting a negative, it's probably your calculator's in the wrong mode. I would bet Ty's life on it. Questions on this one? Okay, so I know what you all are thinking. You're thinking, Mr. Lake, we've got 11 minutes left. Can we do a real world problem? All this stuff you give us all the time is like, when am I going to use this in the real world? And hold on. Anybody need more time to write? And I got your back. I knew that's what you would want. So let's say you're driving on the road and you see a utility pole leaning dangerously next to a puppy that's sleeping on the ground. So you do what any normal person would do. You stop your car, get out a protractor, and measure how much is this pole leaning. And you find that's leaning 8 degrees from true vertical. Okay? You then walk across the street, stopping cars as you go, explaining you're a pre-calculus student, you're allowed to do this. And you measure 22 feet, and then you pull out your orthometer, which you use to measure angles with, and look through the straw or whatever to get the top of the pole, and then measure 43 degrees as your angle from point A. So now what you're going to do is find out how tall the pole is so you can see if the puppy is sleeping too close or if they're a safe distance away. And then you can keep, going on your road, right? Or do you need to move the puppy? That's the question, right? But to know that, you have to know how tall the pole is first. Yay? Yeah. I'm sure this has probably happened to you where you're driving with your parents or guardians somewhere. They probably stopped on the side of the road to do just this very thing. I can give you 3 minutes, but I'll give you hints at regular increments. Somebody in first hour asked, Mr. Lake, why don't you just move the puppy anyway, a safe distance away? Because the puppy's sleeping. Okay, so you don't want to wake the puppy if you don't need to. All right, first thing I would note, you don't need to redraw this, but note that this is just an oblique triangle. Where C is 98 degrees, right? 90 plus 8. So the first thing you need to do on any of these problems is actually tell me what angle C is first. That's the first thing you need to do. What? Jackson, do you have a question, Jackson? You find angle C first. Oh, no, yeah, don't tell me yet. But that's the first thing, because once you have angle C, then we can do A sine of A is equal to C sine of C. Can a remote person tell me, how do I get angle C? Gavin, Osvaldo, Edgar, Teresa? What's angle C? If A is 98 and if B is 98 and C is, I give up. If B is 98 and A is 43, what's left over for my angle C over here? And I'll tell you, it's not 38 and it's not 40. They're shy. I understand that. That's, oh, no, do we got it? Yes, good job, Gavin. It is 39. You subtract 43, subtract 98, find out what's left for angle C, and it turns out that that is not enough room to write. Nope, it's 39 degrees. So now we're just plugging in into this formula. So A over the sine of 43 degrees equals C, which was 22, over the sine of 39 degrees, multiply. A is the sine of 43 times 22 over the sine of 39. Type that into the old calculator. And you get 23.842 feet. You then measure the distance from the base of the pole to the puppy, and the puppy is at 23.9 feet. So you know you can leave the puppy alone. The puppy is a safe 0.05 of a foot away from the top of the pole. Yay? Real life stuff here. It matters. Puppies' lives are in danger without honors pre-calculus. I just imagine, what do all the rest of these people at this school do that don't take honors pre-calc? Just, I bet you those people are also the same type of people that get into pools before measuring their angle of decline. sucker born every minute. All right, you do have 3 minutes left. As a reminder, you can start packing up as we don't have time to do any more. As a reminder, no homework due tomorrow. Homework 6.1 is due Wednesday. So of course, if you wanted to start on it, that'd be a good idea, right? Get a few questions out of the way. But no, you can only do the ones that give you 2 angles and a side. If they give you 2 sides and an angle, we haven't covered that next. That's the next thing we'll do tomorrow. And any problems where they give you 2 angles and a side, you should be able to do it. Just find the 3rd angle and then use the law of sines until everyone's happy. Also, as an update, I told First Hour this morning, I did a pause. I was like, I was looking at our grades for that test that you all took, and like everyone got 100%. That's so wild. You all did really good. And I just let it sit there for a second. They didn't want to make eye contact with me. They didn't look. They're like. Then I told them, well, I do. I saw that I made a mistake. But of course, I'm sure they're just happy now. Just basically get out of the test, which is fair. I think, to be honest, though, if they would have told me, it actually would have been the same consequences. Because once they open it, I think it would have had the settings. So if any of you opened it early, like during seminar, you also would have had the settings for homework instead of a quiz. But I checked and I don't think anyone did. All right, have a good day. See you tomorrow. Bye, everybody.
Bye, Mr. White.
Bye.